Kathy's Gatos here. Welcome to Chapter 7, Lesson number 4, Part 1 of 2 parts for adding and subtracting rational expressions. So before we get into adding and subtracting with variables, let's review how to do that with numbers. So let's say we have classic fraction question, a pizza, and it's divided into 7 pieces. Now, Jason eats 3 of these pieces of pizza, and Carolyn eats 2 of them. So I want to know what fraction of the pizza Jason eats. Well, you can see he ate 3 pieces out of a total of 7. And what fraction of the pizza does Carolyn eat? Well, she has 2 out of the 7. And then we get asked, how much did they eat all together? So what fraction of the pizza was eaten? So we had 3 out of 7 pieces and 2 out of 7 pieces. Well, 3 plus 2 is 5 out of 7. Notice when the denominators are the same, such as this one when they're 7, we keep the denominator the same, we don't add it, and then we just add the numerators. Okay, what about this one here? Now we have a pizza that's divided into 6 pieces. Now Carlos eats half of the pizza. So if I cut half of the pizza, Carlos is eating half of the pizza. Maria eats 1/6 of the pizza. So she just eats that one little piece. So we want to figure out what fraction of the pizza was eaten. So this is a little different because the denominators are not the same. So Carlos is eating half of the pizza. Well, you can see half of the pizza really is 3 out of 6 pieces, or creating an equivalent fraction to go from 2 to 6. I multiply by 3, and to be fair, I multiply this by 3. So half of the pizza is the same as 3/6 of the pizza. And Maria eats 1/6 of the pizza. So add those together, the numerators, and I have 3 plus 1 is 4 out of 6. And remember, we have to put that into lowest terms, which is 2/3. Or another way of adding that is to just do like this, creating a common denominator of 6 and saying, okay, I have to times 2 by 3, so I times 1 by 3. 1 times 3 is 3 plus 1 is 4, and 4 to 6 goes into lowest terms. So those examples show you how to add when the denominators are different and when they're the same. So when they are equal, you add or subtract the numerators over the denominator. Don't add the denominator, and then put it in lowest terms. If the denominators are not equal, you need to find the lowest common denominator and express each fraction as an equivalent fraction with that lowest common denominator. Then again, keep the denominator the same, add the numerators, and simplify. So this is not in your notes, but worth noting. Just like I told you for GCF, there is an LCM button. And so the LCM button is found in the same place as the GCF button. In math, go over to number and lowest common multiple. So let's say I'm adding 2 fractions and they have this as the denominator, 24x cubed and 36x squared y. I want to find the lowest common denominator that both of those can go into. So basically I'm finding a multiple of those 2 numbers, and I want the lowest multiple. So I can find the lowest common multiple on my calculator between 24 and 36, which is 72. And then the lowest common multiple of the variables is the largest exponent. So remember, greatest common factor was the smallest. Lowest common multiple is actually the largest exponent because both numbers need to have that number as a multiple. So it's the largest exponent of each variable, even if it's not common to all terms. So if we look at 24 and 36, the lowest common multiple is 72. And then look at the variables. So x cubed, they both have an x cubed. It doesn't have to be common to both, but I go for the bigger one, which is x cubed. And then I also have to include that y. So putting that together with the number, the lowest common multiple is 72x cubed y. So let's try some with numbers first, and then we'll go on to do it with variables. So looking at the first one, the denominator is 9, so I keep the denominator, and then I just subtract my numerators. So 5 take away 2 is 3 out of 9, and in lowest terms, that's 1/3. Okay, 2/3 plus 2/5. The lowest common multiple between 3 and 5 is 15. So I'm going to create an equivalent fraction out of 15. So to go from 3 to 15, I would multiply by 5. So to be fair, I multiply the numerator by 5 to get 10. To go from 5 to a denominator of 15, I multiply by 3. So I have to do that to the numerator and the denominator to get 6. So now I have equivalent fractions. The fractions have the same denominator, so I will just add those together, which is 16 out of 15. And I'll leave it as an improper fraction, but they don't have any common factors to the numerator or the denominator, so I'm done. Okay, let's try another one. Lowest common multiple between 6 and 4 is 12. Again, the calculator can help you out. So I'm going to create each as an equivalent fraction with 12 as the denominator. So to go from 6 to 12, I multiply by 2. So to be fair, I multiply my numerator by 2. To go from 4 to 12, I multiply by 3. So to be fair, I multiply my numerator by 3. So now that the denominator is the same, I keep my denominator and subtract my numerator. And then I'm left with 7 out of 12, which cannot go any further than that. Okay, so the same process is going to happen when I have variables, okay? The only thing I have to do now is just pay attention to any restrictions. Am I dividing by 0? So looking at this one here, I'm dividing by 3 and dividing by 4. There's no variable, so there's no restriction. So in the first one, my denominator is already the same. So I keep my denominator the same, and then I subtract my numerators. 2x take away x is just x over 3. Okay, and the next one, denominator is the same. So I have 3x plus x. So 3x's plus another x is 4x. Now 4x is the same as 4 times x over 4. And then you can see I have a common factor of 4. So my final answer, I'm just left with x. Okay, and this one here, the denominator is 5, so it stays the same. And I just combine it into one fraction by adding my numerators. So I have 2a's plus 9a's are 11. Negative 3 plus 1, negative 2. Okay, and the next one I'm subtracting. Now when I'm subtracting and I have a binomial numerator, I have to be super careful, and I want to use brackets to subtract the entire numerator. So we're going to place brackets around that because I'm not just subtracting the 4y, I'm also subtracting the 7. So this becomes 5y take away 1, and then take away a 4y and take away a 7. So 5y's take away 4y's is 1. Negative 1 take away 7, negative 8. Okay, looking at this one here, denominator is a number, not a variable, so there's no restrictions. Lowest common multiple between 4 and 10 is 20. So I'm going to change each one to be an equivalent fraction out of 20. So for this one here, I would multiply by 2, so I multiply the numerator by 2. In this one here, I would multiply the denominator by 5. So I also multiply the numerator by 5. So I've created an equivalent fraction with a denominator of 20. So I'm going to now subtract them. Now that the denominator is the same, keep the denominator, subtract the numerators, and if I have 15 x's and I take away 14 of them, I'm just left with 1 x out of 20. Okay, for this one here, I have a binomial. Denominators are different. So lowest common multiple between 3 and 6 is 6. So this one stays the same because it's already out of 6. In this one here, I'm going to multiply the denominator by 2 and also multiply the numerator by 2 as well. Now this time here, we have to be careful because we're multiplying a binomial by 2, so I need to apply the distributive property. So I'm doing 2 times 3a and 2 times 1. So it's 6a minus 2 all over 6. Okay, so now that the denominators are the same, I'm ready to add them. So I keep the denominators the same, and I'm going to add my numerators together. So 6a's plus 4a's are 10a's. Negative 2 plus 5 is 3. Always do a quick check to see if the numerator can be factored. It can't, so that's as far as I can go. Okay, this one here, lowest common multiple between 8 and 3. Well, that would be 24. So I'm going to change each one to be a denominator out of 24. So to go from 3 to 24, I would multiply by 8. So that means I need to multiply my numerator by 8, applying the distributive property. Okay, over here, to go from 8 to 24, I would multiply by 3. So to be fair, I'm going to multiply my numerator by 3, distributive property. 24y, take away 9. Okay, so to subtract these now that they have the same denominator, I'm going to keep my denominator the same and subtract my numerators. Now, remember when you're subtracting, I really recommend you put brackets around your second numerator so you remember to subtract the whole thing. Okay, so here I have 24y, take away 9, take away 16y, take away an 8. So you're subtracting everything. So if I have 24 y's and I take away 16 y's, I'm left with 8. If I have negative 9 and I take away 8, I'm left with 17. So that would be my final answer. Okay, this one here. I want to find the lowest common multiple of the denominators, but 3x doesn't look like it has a denominator. So a little trick for you. Any number can be made a fraction simply by placing it over 1. So I'm going to do this question here, 7x plus 3 over 2 plus 3x over 1, because then I can see the lowest common multiple between 2 and 1 is 2. So this one's out of 2 already, so it'll stay as 2. But I can make this one now out of 2. So if I have 1, I multiply it by 2. 3x times 2 is 6x. And now I can add them because they have the same denominator. So keep my denominator the same and add my numerators together. And then just group your like terms. So 7x's plus 6x's are 13x's. And then we have the plus 3. Again, you can check any one of these questions. I'll show you the check for this one here. You put the original into y1, you put your answer into y2. Remember, the check always occurs in the table, and since these are equal, that means I did this correctly. Okay, let's try this one here using that same trick I showed you. 4 becomes 4 over 1. So lowest common multiple between 1 and 9 is 9. So I'm going to change each to be a denominator of 9. Well, the second one's already 9, so I leave it alone. So here, 1 times 9 is 9. So to be fair, I multiply the numerator, and I get 36 over 9. So now I'm ready to subtract. Again, when you subtract, you place brackets around your entire numerator, and it's over the common denominator. The reason is because I want you to remember that you're not just subtracting a y, but you're subtracting a negative 4, which then becomes a positive 4. And then just group your like terms. So 36 plus 4 is 40, and that will be subtract y. Okay, number 5a, we're going to omit that because in the curriculum, you're only going to do one operation at a time. So now we're going to take what we've been doing, we're going to add some variables into the denominator. So the only thing that makes this a little bit more different is that you have a restriction. So I have a restriction of 2a can't be 0. 2a is a monomial, and monomials always have restriction that variable can't be 0. So the denominator is already the same, so I keep it the same, and then I combine by adding my numerators together. So I'm going to have 5a plus a is 6a. 3 take away 6 is negative 3. And then I always look to see, can I factor my numerator? So in my numerator, I have a GCF of 3 that I'll take out. So 6a divided by 3 is 2a. Take away 3 divided by 3 is 1. Okay, and that will be as far as I can go. Factored form is simplest form. This is how I want you to leave your answer. Again, remember, you cannot cancel these 2's because this is not a 2 in the numerator. It's a 2a minus 1. But always leave your answer in factored form. Okay, let's try this one. So for this one, the denominator is the same. It's 3y minus 1. I have a restriction that y cannot equal to 1/3. So I'm going to keep my denominator and put it over my numerator, 3y minus 1. So I have 3y minus 1 over 3y minus 1. These are the exact same thing. So the answer simplifies to be just 1. Okay, let's try this one here. So they both have a denominator of x plus 3. Restriction, x can't be negative 3. I'm subtracting, so I'm going to use brackets so that I remember to subtract my entire numerator. So this will be 4x plus 10 minus 2x minus 4. So 4x take away 2x is 2x. 10 take away 4 is 6. I can factor a GCF of 2 out. So 2x divided by 2 is x, plus 6 divided by 2 is 3. I have a common factor, x plus 3 and x plus 3. So the whole thing simplifies to just be 2. Okay, so always, there have a note here, always make sure that your answer is in lowest terms. And that's the reason that we factor, just to see if we have any common factors that we can remove. Okay, let's try this one here. So 3p and 7p. So first thing I want to do is come up with the lowest common multiple between 3 and 7, and that's 21. Lowest common multiple between p and p is just p. So I'm going to change each one to be out of 21p. So to go from 7p to 21p, I multiply by 3. So to be fair, I multiply my numerator by 3. To go from 3p to 21p, I multiply by 7. So to be fair, I multiplied this guy by 7 as well. And then I'm ready to add. So p can't be 0, monomial can't be 0. And I now have the same denominator, so I keep the denominator and I add my numerator. So 35 plus 6, that's 41 over 21p, final answer. Okay, what about this one here? 1 over 3y plus 6 over 5. So lowest common multiple between 3 and 5 is 15, and I need a y. So it has to be a multiple of both numbers. So to go from 3y to 15y, I would multiply by 5. So I multiply my numerator by 5. To go from 5 to 15y, I would multiply by 3y. So I will multiply my numerator by 3y as well. Now they have the same denominator, so I can add them together. So restriction that monomial can't be equal to 0, which is a restriction that y can't be equal to 0. Now that the denominator is the same, I keep my denominator and I add my numerators together. Now you can leave it like that. That's a good way, but a better way is to write your variable first. So you won't get the question wrong if you leave it like that. This is just a better way when we have our variable first. Okay, let's look at this one here. Denominators of 3x and 6x. So lowest common multiple between 6 and 3 is 6. Lowest common multiple between x and x is just x. So these are both out of 6x. So this one stays the same. To go from 3x to 6x, I would multiply by 2. So to be fair, I'll multiply my numerator by 2. Because it's a binomial, apply the distributive property. Okay, so now that the denominators are the same, I'm ready to add. So because the denominator is a monomial, the restriction is variable can't be 0. So I'm going to keep my denominator the same. I'll combine it as one fraction by subtracting the numerators. Placing brackets around because I'm going to subtract the entire numerator. So 2x minus 5, take away 6x, take away a negative 4 is a positive 4. So 2x take away 6x is negative 4x. Negative 5 plus 4, negative 1. And that would be my final answer. And then last one here, I have over 2a squared and over 5a. So lowest common multiple between 2 and 5 is 10. And between a squared and a is a squared, the higher of the two. And you can see here why we need to do this, because it needs to be a multiple of both. If I just chose a squared is not a multiple of a. So that's why we choose the higher. So to go from 2a squared to 10a squared, I'm going to multiply by 5. Distributive property, I get 5a plus 35. To go from 5a to 10a squared, I would multiply by 2a. So 3 times 2a is 6a. So I'm going to keep my denominator the same and add the numerators together. Because the denominator is a monomial, the restriction is a can't be 0. So I'm going to have 5a plus 35 take away 6a. So 5a take away 6a is a negative a. Add that on to 35. Okay, so to summarize the lesson. If the denominators are the same, add or subtract the numerators term by term, keeping the denominator the same. If the denominators are not the same, you need to create equivalent fractions with the lowest common multiple. I want you to always state restrictions for your denominator, and then always state your final answer in lowest terms. So fractions, they're really important, and you could actually say there's a fine line between a numerator and a denominator. So when you guys are done this lesson here, you can work on your assignment, a couple questions to omit on the bottom. I hope this video helped, and I look forward to seeing you for the next one.